Alright, happy 4-day weekend, guys. We decided to record some videos to help you out for reviewing. Those of you who are going to review tonight or even on Wednesday for your test, whether you're going to be taking it on Thursday or Friday. So putting this out tonight will give you at least 2 good days of review that you can not only access the online copy with written answers, but you could also view these instructional videos. Alright, so let's go ahead and begin. Number 1 through 4 are asking from the answer blank, find a function in factored form to match each graph. Okay, so you see all of these options here that you can choose from, and each one only is going to be matched with one letter. So let's go ahead and begin. The first thing that we'll notice is on number 1 is that we have 3 intercepts. Okay, we also see that we have 2 changes of direction. Furthermore, we know that we are going to infinity as x increases, and as x decreases, the graph is going to negative infinity. Okay, so let's start analyzing the pieces that we can see. So if we see 3x intercepts, okay, so 3x intercepts are going to show that there's going to be 3 factors of some sort. Okay, so 3x intercepts, and these are real because they're actually crossing the x-axis. We have 2 changes of direction. Okay, so I'll just put COD, changes of direction. And then as we go to infinity, it's going to go positive. So we need to find something that has a positive x with the multiplicity of, or with the powers combined to get 3. Alright, so we have like x squared and x, that could be a possibility. We have x squared and x there, okay, that's also a possibility. We have x to the 1, x to the 1, and x to the 1, all multiplied out would give us cubic. So we're noticing that all of these, x squared again with x, all of these look like they're going to be x to the power of 3, okay, except actually this one, as I was saying that. This looks like it's going to be power of 4, because it is x to the power of 2, which would be x squared, and then you have 2 more x's to give you that x to the 4th. Okay, so we're kind of like finding the similarities and differences between our answer bank. Okay, we also have another x to the 2, then x to the 1, and x to the 1 that would distribute out or fall out and give us another x to the 4th. So these last 3 answers look like they're going to be related to x to the 4ths. Okay, all the other ones over here look like they're going to be related with x cubed. Okay, so let's talk about this. X cubed will have, since the power is 3, think of that n minus 1 from our notes, it's going to have 2 changes of direction. Okay, and then this x to the 4th can have 3 changes of direction. So I can look at my graphs, and these changes of direction here, there's 2, and then here there's 3, here there's 3. So we know that this will have an x 4th of some kind, this would have an x 4th, these will have x cubes, and now we have to just look at the other attributes of all these graphs. Okay, let's look at the x-intercepts. So specifically, we can see that this one has an x-intercept at -2. Okay, so let me go ahead and write -2. This one has x is equal to 0, and this has x is equal to 3. So if these are the x-intercepts, they can be written in factored form as the opposite. So x plus 2, this is just x. And since it's a positive 3, we would write it as x minus 3. Just a quick reminder, these x-intercepts are representing that x value that would make each of these factors equal 0. Okay, so if I plugged in this 0 here for x, it would make the whole product 0 because all of these factors are multiplying. Okay, and then last but not least, at x is equal to -2, if I plugged in -2 there, it would make this binomial factor equal 0. So all of these are my zeros, if you will, in factored form. Okay, so let's look for an x plus 2, an x, and an x minus 3. Okay, so we have x plus 2, we have an x, and we have an x minus 3. So it looks like the answer for number 1 is going to be E. Okay? All of those x values are positive, and if you see that real quick and start analyzing all of these, as far as going off to infinity, as x goes to infinity, f of x will also go to infinity. So all of these have positive coefficients, which so do all of the functions in our possible answers bank. You don't have like a negative out in front of any of these that would make a possibility of the whole thing being negative. Okay? So all of them look like they're positive and they're going up as x approaches infinity. Okay, so it looks like all we're going to do now is just concentrate on our continued zeros of the function, our x intercepts. So we have x is equal to -2, we have x is equal to 0, we have x is equal to a positive 3. Okay. Now we have to be careful because all of these in number 1 went through the x-axis. This one right here is about to bounce. So this factor, which is going to be written as x minus 3, actually has a multiplicity of 2 because it bounces off the x-axis. Otherwise, if it goes through, that means it's going to have a power that's not going to be an even number, but an odd number, like 1, 3, 5, so on and so forth. Okay? So this x is equal to 0 will just be x by itself. And if you want to interpret it as x to the power of 1, it verifies that 1 is odd, so it would cut through the x-axis. And then x is equal to -2 will be written as x plus 2. So these would be the zeros. Again, that means if x is -2, plugged in here, would make that whole piece 0. If x is equal to 0, plugged in here, would make the whole answer equal to 0. And if x is equal to 3, plugged in here, it would make all of this stuff, and when I say the whole answer, I'm talking about all of this, would equal 0. Okay? Because multiplication, if you're multiplying any piece by 0, the whole thing equals 0. Okay, so now what we're looking for is this x plus 2 with the multiplicity of 2. Okay, so let's find multiplicities of 2, and it looks like our answer there is going to actually be f. So we have the x minus 3 raised to the power of 2, and we have x plus 2. So f would be the answer there. All right. So now we do have another one that's bouncing here, and we can go straight to that, and it looks like it's bouncing at x is equal to 2. So now let's try to get a little shortcut with this. As far as putting it in factored form, it'd be x minus 2, and because it bounces, it's going to be x minus 2 squared. So let's find our x minus 2 squared pieces on the remaining answers. Okay, so that's where they will exist. And now I have two answers that I can use for number 4. This one is x is equal to 0, so that'll just be x. And this is -3. And again, we have to remember that it's the opposite of what our x-intercepts are. So that means I could plug in -3 right here, which would make this small binomial equal to 0, which multiplied with all the other binomials will make the entire thing equal to 0. Just a reminder on that algebra part. Okay, so we want the one that says x plus 3 and then x minus 2 squared, and then we need this x. So we need this x here at the ending because it's going through x is equal to 0. Okay, so the only one that would work on that one, although those two are, although a and h are close, h is going to be the one that happens. And h happens because this one does not have another x. This one only shows x cubed because there's x to the 1 and x squared. We need something that will give us x to the 4th. There's this x squared, there's this x, and finally this other one. So when we would multiply them, they would give me x to the 4th. Which again, this is x to the 4th, this is x to the 4th, and these two are x cubes. Okay, so last but not least, I have one at 2. I'm going to go ahead and skip that step. Since it's at +2, I'm going to write it as the binomial x minus 2. This is at x is equal to 0. That's still x. And this is at negative 3. So again, we're interpreting the opposite with these binomial factors. So it'll be x plus 3. So all of these have multiplicity of 1 because nothing bounces off the x-axis. So we want to find x, x plus 3, and x minus 2. And it looks like C is going to satisfy that. We have x plus 3, because again, that's where this was x is equal to negative 3. And then we have x plus 2, because that's where this was x is equal to a positive 2. Okay, just remember the relationship that exists between, let me go ahead and highlight it kind of big, our independent binomials and their pertaining roots. Okay, x minus 2 comes from x is equal to 2. And that's how you do 1, 2, 3, and 4 on the review.